Earthworks and drainage. Geotechnical testing. An essential step before commencing any construction or structural engineering project is extracting and testing soil sections at the building site. This process allows for the determination of various soil properties, such as its structure, composition across different layers, the top layer of the load-bearing subsoil, and the level of the groundwater table. Soil improvement. When the bearing capacity parameters of the soil are not optimal, several techniques can be employed for soil improvement. One approach is soil consolidation, which may involve compaction through tamping or vibration, grouting using cement-based or chemical materials, heat treatment via soil freezing or incineration. If necessary, soil replacement can be carried out, wherein layers of compacted crushed stone are utilized to replace soil with insufficient bearing capacity. Drainage. In instances of high groundwater levels, it becomes necessary to dewater the work area to facilitate construction below ground level. This can be achieved through methods such as open sump pumping, groundwater drawdown, electroosmosis, or soil freezing. Earthworks. Clearance work, involving the removal of vegetation, excavation of the topsoil humus, typically 20 to 50 centimeters in depth. Extraction of soil blocks, often done mechanically. Disposal of excavated soil, shoring and strutting. Backfilling and compaction, landscaping. Work trench shoring. With slope, shoring can be set up to match the natural slope angle of the soil, but there are depth limits to this approach. Typically, for different soil types, there are recommended depths: 50 centimeters for silty soils, 75 centimeters for sandy gravel soils, 100 centimeters for medium compact soils, and 150 centimeters for dry clay soils. Beyond a depth of 200 centimeters in hard clay soils, it is recommended to use shoring techniques with strutting. In narrow working pits, shoring is accomplished using wooden planks held together with straps on both sides of the trench. The straps are connected by horizontal struts, so the opposing earth walls essentially support each other. The planks can be placed before or after excavation work begins. While post-shoring can be horizontal or vertical, pre-shoring is only feasible in a vertical configuration. Step shoring is employed in work pits deeper than 3 meters. For wide trenches, single-sided or double-sided shoring may be utilized. Single-sided shoring typically involves vertical straps supporting horizontal planking, while the straps are supported by inclined struts or anchored to piles. Double-sided or framed shoring is used for rectangular trenches with a maximum width of 6 to 7 meters. In this case, horizontal straps support the vertical planking, creating continuous frames. Specialized shoring methods include Siemens shoring, which utilizes I-beams for support, and prefabricated metal shoring structures consisting of interconnected shoring panels fixed onto support frames, interconnected by tubes. For deep excavations, steel sheet piles or concrete piles are driven into the ground with a pile driver. These piles are interconnected with flanges to form a completely closed wall, with steel piles being easily driven in and removed. The concrete piles remain in place, becoming permanent structures even after construction is completed.